Hey everyone, just another intro into our next lesson. So we're going to be working with circles. You probably wonder what circles have to do with quadratics, but if you look at the formula for a circle, or the equation of a circle, x minus h squared, so there's our quadratic, plus y minus k squared, another quadratic, equals r squared. What each part of that means is x is just our variable, y is just our variable, h is the x coordinate of our center, so we're looking on a coordinate plane for our circle, and k is the y coordinate of our center. R is just simply our radius, it's going to be a number. So let's just work with our formula real quick. Say I give you this circle with the center at negative 11, negative 18, and a radius of 4. Let's try and work with that. So we use our formula, x minus h squared plus y minus k squared equals r squared. And all we're doing is plugging in. So we're going to take our center, this is our h, this is our k, and we do x minus h, then it's negative, so it'd be minus minus would be plus 11 squared plus y plus 18, again minus minus, squared equals our radius 4 squared. Okay, so now we're at x plus 11 squared plus y plus 18 squared equals 16. And that's just a simple formula of a circle. It's the equation for a circle with center, negative 11, negative 18, or a radius of 4. So fairly simple and not really testing a lot of skills we've used so far. So let's try something that gives us more of an issue. If we have this standard form equation, or, well, jumbled up equation that we could put in standard form, we're going to try and make this into the equation of a circle. Now, you're probably wondering how this can ever turn into that. Well, we're going to use completing the square because that gives us binomial squared. And that's what we have in our equation of a circle. So if we look at this and we're thinking about putting it into something that we can use completing the square from, we need all our terms of variables on one side and all our constants on the other. So let's take this y squared and put it with the rest of its friends. So we'll have, and let's just put this in standard form from x's down to y's, x squared plus 8x plus y squared minus 2y equals 64. Now, if I had a constant in front of my x squared or my y squared, I have to divide that out, right? We can't have a leading coefficient here. But since we have just x squared and y squared, we're good to go, and we're good to start completing our square. So we're going to do this sort of in a group. We're going to do these two first, and these two second. So to complete the square over here, we have x squared plus bx. We're going to take b over 2 and square it. So that's 4 squared, or 16. So we have x squared plus 8x plus 16. We're going to add that 16 over here as well. But we won't do that yet because we're going to add some other things over there. For this one, we have y squared minus 2y. So we have negative 2 over 1 squared, which is, sorry, negative 2 over 2 squared, which is negative 1 squared, or 1. So we say plus y squared minus 2y plus 1 equals. So we have 64. And along with the 64, we need to add what our b over 2 squareds were. So 16 and 1 also need to be added to 64. And now we're ready. Actually, if you break this down into two binomials from this perfect square trinomial, we will end up with the equation of a circle. So this side we get x plus our b over 2, which is 4 because this is a positive, and then plus y minus our b over 2 because that was a negative, and that's all going to equal 81. So clearly our radius was 9 because 9 squared gives us 81, and the center of our circle is at negative 4, 1. So our center is at -4, 1, and our radius is 9. So that's how you use completing the square to solve for the equation of the circle. It's actually a lot easier than it seems, and I'm going to put up a video after this about completing the square, just a review. So take a look at this. This is what we'll be doing in class tomorrow. Thanks.